Hey everybody, it's Dr. Wallace again. I'm going to do some problems from Unit 4 of Math 1001. Okay, put that here. All right, so here's some problems we're going to try. Unit 4 is all about analyzing data and probability. So probability is one way you can analyze data. And it's useful in the study of statistics. So a lot of the stuff we're going to do on the calculator, if you're going to use your calculator to help you, is under the stat menu. So it's like statistics class here. So anyway, first part we're going to talk about is in section 10.1 about basic concepts of probability. Probability is the likelihood, the theoretical likelihood that an event is going to happen. The formula is basically the probability that an event occurs is the number of times it occurs, theoretically, versus the total possibilities that are allowed, okay? So the classical probability experiments are drawing cards from a deck of cards. So the possible cards you could get would be 52. There are 52 different cards, okay? That would be the denominator there. And, you know, the probability would, or the size here would be the number of cards that are in your sort of favorable outcomes that you're looking for. Other things would be probability of, you know, getting a heads when you flip a coin, okay? Where everyone knows what that probability is. One head out of two, because the possibilities are head, tails, okay? If we flip a coin more than once, now it gets a little more complicated. Or if we talk about drawing cards and not putting them back in and shuffling, gets more complicated. We're not going to do a lot of that stuff in this class, but you would if you moved on in the program and did more probability. Anyway, what you might have noticed about probability is that you can't get a number, since it's a ratio of a subset of something divided by the total possible things, okay? You can't get a number that's negative or bigger than 1. So probability is a ratio of number of times then something we care about happens divided by the total number of possibilities that are in the realm of likelihood. Probabilities. Okay. So the something has to be in one of these. So this is a subset of those. So you can never have the probability of an event be negative or bigger than 1 as a decimal, okay? So determine which of these could be a probability. Well, this is the only one that can be a probability, right? This one's bigger than 1, that's one negative. So right there, you know, when someone says I can give 110%, wrong, right? If you give 100%, first of all, that means you died because you gave it your literal all, okay? But giving 110%, that would be like having a probability that's greater than 1. That's no good, okay? Not allowed. All right, of course, if you want to find decimal, percentage, or fraction. Okay, you can let your calculator help you with these, but one way to do that is so you can put in the decimal here and go to math arrow frac. You can change it to a fraction, but if you just know how to read that right in hundredths, so another way to write that is 27 over 100, and as a fraction, that's 27%. All right. Okay. So this is that one. The next one is 4/3, right? Well, 4/3, if we type that into our calculator, would come out to be 1 1/3, or 1 and 3 repeating as a decimal, okay, which would be 133.3 repeating percent, okay. This one here, we know this is probability, or could be probability of something, check. Okay, because it is between 0 and 1. This one is not probability of something. Because it's bigger than 100%, or bigger than 1 as a decimal, right? Lastly, negative 2.5%. Well, that's negative 25 over 1,000, because that's 2.5 over 100. If I had done 2.5 100ths, as a reduced fraction, I could write that as 1/40th, or 25 over 1,000. Okay, that's the same number. Okay, so your calculator will give you the reduced fraction and the decimal if you need it. And of course, that's not probability either. Okay, so moving along. Let's do sort of a classical problem here. These are like the kind that they put on the SAT or the LSAT, maybe, for law school. So probability is size, and when I say size, I just mean the count, right, of the event. So, and the sample space, that's S, that's the total number of possibilities. So sample space S is, well, or the size of S would be the total number of marbles, so that's 21, okay? So as fractions, right, each of these probabilities will have divided by 21, perhaps, unless we can simplify it as a reduced fraction. Sample space, though, is actually the set of all possible things. Now, each of these marbles, even though you pull out a red one, right, it's indistinguishable from any other red one, okay? You have to treat each of them as separate possible answers. So I would just say, okay, think of them as having numbers. So red 1, red 2, red 3, red 4. Okay, then you'd have blue 1, blue 2, blue 3, on up to blue 8. So each of those would be a different possible value, okay, in your sample space. Green 1 all the way up to green 9. Okay? And so those are all the possible things that we could get if we if we pick out one marble, right? So I could either get a red, a blue, or a green, but thinking about them as having numbers will allow you to count them correctly when we're doing probability. So part 2 asks, what's the probability of drawing a red? Well, that's the size of the favorable outcomes, which either I get red 1, red 2, red 3, or red 4. And then the size of S, okay, is 21, right? The total number of marbles. So 4 out of 21, I have a 4 out of 21 chance to get a red marble. Does that make sense? All right. Oops, that's supposed to be a 3. Okay. When you put conjunctions in there, then you have to use maybe some common sense or a formula to get the answer. Okay. This is called the summation rule. So the probability of getting one or another thing is the probability of getting one of them plus the probability of getting the other minus the things that you double counted. So an example of this would be like the probability of drawing a king or a club from a deck of cards, right? So that's, you got 4 kings in the deck. You've got 13 clubs in the deck, but you double counted the king of clubs when you first counted, right? And so if you think about just counting up all the kings or the clubs, right, you would get 16 items that are either a king or a club, and then that's out of 52. That's what I get here, right? 17 minus 1. So this is the example that I was hoping would make this more clear. Now in this case, these two events, getting a red marble and a green marble, those are called mutually exclusive, which means you can't have them both at the same time. So this probability of A and B will be 0, which is really troublesome, because you might think if you have an or here, you just add up the probabilities, and that's not always the case, right? Because you could be double counting. So this comes out to 13 out of 21. There are 13 red or green marbles, right? And you can't have a red and a green marble if you only are allowed to draw once. When you say, what's the probability that something does not occur? That's called the rule of, then we use the rule of complements, because it's possible that counting up the number of times something does not occur is easier than, or sometimes sometimes it's easier to count the number of times something does not occur than the times it does. So, for example, what's the probability that you get 1 heads in 10 tosses of a coin? Well, that means not all tails, okay? So sometimes it's easier to count up the number of outcomes that are not favorable than it is to count up the number of outcomes that are favorable. In this case, well, and they, since the total probability would be outcomes in S divided by the number of outcomes in S, the total probability is 1, right? 100%. Okay. So if you count up the number of ways you don't have a red, plus the number of ways you can have a red, that should add up to the sample size, right? So if you divide then by the size of the sample size, you should get 1. So this would be 1 minus, we already found the probability of getting a red, which is 4/21. So this would be 17/21, right? There are 17 marbles that aren't red. And of course, our example of, say I wanted to get something that wasn't a king. Well, I already know how many kings there are. There are 4 out of 52 would be the probability of getting a king. So not getting a king when you draw a card would be 52 out of 52 minus 4 out of 52. Okay. All right. Gathering data. Using sample. Okay. Sampling is how we find statistics. So a statistic is a number or characteristic of what's called a sample. Sample is a subset of the population of individuals or items or things that you're concerned about in a study. So we'd like to know, for example, how many people are going to vote for a certain candidate. Okay. Now, it's sort of hard to count that, right? We're in an election right now. Counting up all of the ballots is difficult, okay? But we might be within a very small margin of error, a accurate or approximation to that aspect of the population, which would be the total number of votes for one candidate or the other, by only seeing what a subset or a small sample of people, how they voted. Okay, such things called exit polls. You can use exit polls to help you do that. This is how they make predictions about who won a state even before all the state has counted all the ballots. Okay, to get useful data though, you have to have a random sample that is representative of the population. Okay, so here, for example, a math professor decides to collect data about all Math 1001 students, but only surveys those who attend her in-person intro session. This is called a convenience. This is a sample of convenience, right? It's convenient for the researcher here to survey the students that are, at hand, but it's not random, right? And it might be representative of the population. You might have just a general representative sample that goes to this intercession, but you have no idea that that's the case. So getting data this way is useful as anecdotal evidence, but not the best statistical significant evidence. On the other hand, here the same math professor administers a different survey, this during the Unit 1 in-person session, but instead of sampling only those that go there, she assigns every student that's in her class, and here this professor is once again only worried about her class. She picks 9 numbers out of a hat and surveys the corresponding students. Is this a random sample? Yes, right? We're assuming she's not cheating by picking the numbers out of the hat. This is a random sample. But depending on the population, is the population her her students only, or and that would be the case, then this would be a random sample that is representative of the population. If the population, though, is all Math 1001 students, then this technically would not be a random sample because not all students in the population have a chance to get picked. So here, maybe if I take this off, then now it would be a random sample for all of the students. Okay. Survey of 20 people report their smartphones most used application. This is the raw data, okay? Data is sometimes just given as a set of entries, okay? You might be able to make heads or tails of this right away, or maybe not, okay? So this is why we need to have better ways to display the data, okay? It says make a frequency distribution or relative frequency distribution. Okay, frequency distribution this is a chart or a table of all values of a variable. Okay, so in this case, the variable is most used app. Okay, together with their frequencies. Frequencies are the count, okay, or tally. So frequency distribution is just a tally chart. Okay, so I've done it ahead of time. YouTube comes up 6 times. So this is the variable value. Sometimes we use X for the value, the variable. Then the frequency is here, the tally. Okay. Then Chrome comes up 7 times. TikTok comes up 4 times. And Instagram 3 times. Okay. If you add all these up, that's going to be 20. There are 20 data values, right? That's called the total frequency. And what does this have to do with probability? Well, think about it this way, right? The number of times someone picked, said they wanted YouTube, divided by the total number of responses, that's like a probability, okay? So it turns out that there's a theorem that says the relative frequency, so what is that? Relative frequency is the frequency divided by the total frequency, okay? Relative frequency is probability. Okay, or at least estimates probability. Okay, so relative frequency, let me write it this way. This is the frequency divided by the total frequency. Think about total frequency, that's like the sample size. Frequency is like the number of times the event occurs, right? So relative frequency of something, a data value, is like the probability. All right, as the total frequency goes up, right? So as we ask, if the sample size goes up and up and up, right, then the experimental relative frequency gets closer and closer to the theoretical probability. That's called the law of large numbers. Okay. Anyway, that's where this all comes from. Bar graph, pie chart. Bar graph is just, you put all the possible values of a variable at the horizontal axis. So we got YouTube, we got Chrome, we got TikTok, and we got Instagram. And the height of the bars represents the frequency. So YouTube got 6, Chrome got 7, TikTok was 4, Instagram was 3. Okay, if I rearrange these so that they go from highest to shortest, that's called a pair 2 chart, but anyway, that's not a big deal. Anyway, the scale of the vertical axis is either using frequency or relative frequency. Note, the relative frequency bar graph would look exactly the same. The only difference would be I would scale the vertical axis by dividing everything by 20, right? So now it goes from 0 to 7 out of 20, basically. You get the exact same graph. On the other hand, if I want to make a pie chart, I have to use relative frequencies there. Okay. In this case, I'm gonna break up my pie chart into 20 equal pieces. Okay. Note, you can, to find the angle for a given value, all right, you can take it's the relative frequency, multiply it by 360 degrees, okay? Or in this case, I'm just going to count up little pie pieces, okay? So YouTube got 6 pie pieces, right? So I'm going to make that blue. So that's 2. This is going to be hard on here. 1, 2, 3, 4, 5, 6. I think I did too many. 1, 2, 3, 4, 5, 6. No, yeah, I did too many. All right. And then Chrome gets 7, so I'm gonna make that red. 1, 2, 3, 4, 5, 6, 7. TikTok was 3. Let's make that green. And Instagram, orange, that's 4. It should be 4 left. 1, 2, 3, 4. Okay, so Instagram, TikTok, Chrome, and YouTube. Okay. Measures of spread in sections 11.3 to 11.4. Okay. Consider the data below, listing the number of hours logged in Alex for 10 students. Organize the data into ascending order, find the mean, median, the mode, find the range, and the standard deviation. Let's try to do this right quick, okay? So organize the data into ascending order. So that's 1, 2, 3, 2 4s, and then a 5, then a 7, 10, 12, and 20. Okay, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10, okay? The mean. This is the average. All right? That is the sum of the data values divided by the sample size. So that's this capital sigma means sum. We know how to do this. So you just take all the numbers, add them up, divide by 10. I think it's better to use your calculator. So if I click on Stat, Edit, and I enter the data, 4, 2, I don't have to put them in ascending order now. I can just put them as they're written. Okay, then I go to Stat, Calculate, 1 var stats. 1 var stats is statistics for one variable data. So that's what this is. So we could use TI 84 or 83. Okay, they both do the same thing. By clicking the Stat button, go into the Edit menu, and you enter the data into list 1. Then click Stat, go over to Calc, and find number 1. Oops, sorry, number 1. Which is 1 var stats. Shoot. Gosh darn it, why does it do that? Ah. There we go. And then X bar is your mean. That's 6.8 in this case. Oh, dang it, stop doing that. The calculator will also find the median for you. Median is the one in the middle. If you have an odd number of data values, or the average of the 2 in the middle, if n is even, right? So in this case, once you list them from least to greatest, right, we count 1, 2, 3, 4. 4 and 5 are in the middle. So I would get 4 plus 5 over 2 is the average of the two in the middle. That's 4.5. But if you use one of our stats and you scroll down, it tells you the median is 4.5 immediately. Okay. Then it says find the range and standard deviation. So range is the maximum data value minus the minimum data value. In this case, that is 20 minus 1, or 19. That's a measure of how spread out the data is. Standard deviation. If you use one of our stats, in this case, it is the S sub x, because we are using sample. Okay, sample. This is a sample. This isn't this isn't for all students in Math 1111. Okay, this is a sample of them. The sigma, that would be the population. That would be if we had data for the entire population. Now, the way we solve this, you take the data values and you take their difference from the mean and you square them up. Then you add all those up and then you take the sample size minus 1. Then you take the square root of the whole shebang. Okay? Or if you have the population values, this is the formula for that. Okay? But I don't think you need to worry about that. This is this is the formula for the sample standard deviation. Or you could just use your calculator to find it. Now, on your project, one of your projects, it asks you to do this by hand. So for this problem, the answer is about 5.789. I don't think you should do this by hand very often, okay? But let me show you how it works, all right? So think about this. So we know X bar is 6.8, right? We know little n is 10. X bar is 6.8. N is 10. So what we would get is we would take, so S is the sum of all the squared deviations. So on the one hand, we have 1 minus 6.8, and we square that. Oops, I didn't mean to make it so small. 1 minus 6.8, we square that. Then we take the next data value, which is 2. 2 minus 6.8 in parentheses squared. Then we do 3 is the next one. Then 4. And then 4 again. Okay. And so on until we get all of them all together. Then we're going to divide everything by 9. Then take the square root. Okay. That's how this works. Part 4 asks, what if we deleted the data value 20? Well, Oh, I didn't get the mode. Sorry. Up here, the mode is the most frequent. Okay. Here, if I take stat edit and I take away the data value 20, delete 20, okay? Now I have only 9 data values. If I go to stat, calc, one variable data stats, now my mean is different. The n is now 9, so the number of data values has gone down. The median is 4. Note that if I take away 20, right, take away 20, now 4 is the one in the middle. Right, there's a unique one in the middle, so that changed the median only a little bit. The mode hasn't changed at all. Standard deviation has gone down a little bit, 3.67 roughly. Okay, and the range is now 12 minus 1 over, 12 minus 1, just 12 minus 1. Right, because the new maximum is now 12, and so that becomes 11. So when you take away an extreme value, or maybe like an outlier, in the case where you get data that's wildly ridiculous, if you take those out, then it can affect your mean and your standard deviation quite a lot. Anyway, that's all we're gonna do for today. So thanks for listening, and I'll see you in virtual land, hopefully, and maybe in person someday. Bye.